Hiya. So today we are working on another problem statement, which is an LLD question, a very famous LLD problem, design Amazon locker. So this has been asked to multiple people at multiple times in SDE-2 interviews at Amazon. That is why I'm targeting this problem. It was also there in our LLD problems sheet, so it is present here. That is why we are also taking this up. Also, it is a very important problem. So before we dive deep into the problem, we created some steps in the previous video for solving any question in any LLD round. So I have just done few changes to these steps. So first one is system flow. This is, as I said, an implicit step which we need to perform so that we are clear of what the system is formatting. We should be clear about the system flow. Only then we would be able to work on any of the other steps. The second step is functional requirements. We have to gather the requirements, especially the functional requirements for an LLD round. The third step is identifying the core entities. Now, these third and the fourth step, they are somewhere, they are connected. So first we identify the entities and then we identify the relationship among them and, figure out what the core attributes and the necessary methods are. Along with this, we also prepare the class diagram. So in some of the interviews, you will see that this human diagram step is the focus. Okay. Then I've added a new step, which is API design, which I figured out by reading many interview experiences that, some companies are also asking API design. That is why I've added it here. Next is translating our design into code. Basically, this is what we engineers love the most. We have to write the code. Okay. The next step is discuss the design patterns used and the design principles as well. So this is also an important point because somewhere, the interviewer is expecting you to use certain important design patterns and design principles. That is why we have to use them when writing the code and we discuss them when explaining it. Okay. Eighth is obviously the further improvements, which if you have something in your mind, you can discuss. Otherwise, you can ask for your interviewer if they have some improvements for your system. So these are the steps. Okay. So now what we would do is we would, work on this problem and we will fill up all of these and, try to solve this question. Okay, let's get started. Okay. So let's talk about the system flow. The system flow is basically we are talking about an Amazon locker service. Okay. So what happens is that the customer will place an order. Okay. And the order, once confirmed, is placed in a package inside a locker by the delivery agent. When the order is confirmed, what the delivery agent will do, they will place the order or the package inside a locker. Okay. And as the order is placed inside the locker, we send an OTP to the customer. So the OTP will be used at the time of opening the locker by the customer. Also, we attach a expiry duration to the locker so that if the order is not picked up within, let's say, 3 days, so we can, free or, we can empty the locker and make it available for reuse. Okay, so what the customer does is they can use the OTP and they can retrieve the package. And once it is picked up, the locker becomes free. One more thing that we can add here is that we also have the return. So in return use case, basically where a customer wants to return, similar flow is present. The customer will place the package in the locker. Place the package in a locker and the delivery agent will take it from there. Okay. So we have a similar flow for return as well, and return is an important use case. Okay. So let's move on to the requirements. Okay. So we have identified the functional requirements. So the requirements are allocate a locker for a package depending on the package size. Okay. Whatever the package size is and the locker size. So as soon as we have allocated the locker, we can mark it as reserved. Okay. And what we can do is when the locker is allocated, we can generate an OTP for that locker. And the OTP and the locker details may be sent to the customer. And once the package is placed in the locker, we mark it as occupied. Okay, and customer can unlock the locker using OTP. And once package is taken by the customer, we mark it as free. Similarly, customer can initiate a return and place the package in a locker. And OTP must be generated for the delivery person to retrieve the return package. So here if you see, we haven't done anything different. Just from the system flow, we have identified the core requirements. Like from this line, we are able to understand that we have to allocate a locker for the package. And then we have to inform the OTP to the customer and the other details as well. Okay. So yeah, I have followed the system flow to figure out these requirements. Okay. Now let's move on to the next step, which is identifying the core entities. Okay. So we have identified the core entities. So when I say domain entities, I mean these are the models. Okay. These are the models present in our code. Okay. So the models, you can simply go through your functional requirements and pick up the nouns from there. Like here is a noun, locker. Here is a noun, package. Here is a noun, customer. Then we have a noun, delivery agent. Okay, delivery person. So we just have to pick up the nouns, basically the actors who will be performing the operations or on whom we will be performing the operations. Okay. I have taken an additional model admin, which is useful in such cases. You know, admin can perform certain meta tasks for us, okay, which the customer and the delivery agent cannot perform. That is why I have taken up admin. Apart from that, we have services and controllers. So these are separate classes, okay, like locker controller. So we can have a locker controller which will handle the API calls related to locker. We can have a locker service where the core business logic will lie, which is relating to the lockers. Then we can have an OTP service because obviously we need a service which can generate and validate the OTPs. A notification service which can send the OTP and the locker details. And an admin service which can handle the admin workflows, because if we have an admin model, we need a service to control that model. Yeah, let's move on to the relationships and class diagram. So we have identified the relationships and also developed the class diagram. So basically here we have locker. So let's go to the unit, okay, for locker. For locker, we have identified the relationships in class diagram. Let's go through them. Class locker, we have ID. So we have only the bare minimum attributes we would require for our design. Okay, so for locker, we have locker status, locker size, okay, defined as SL and XL, locker status P, reserved or occupied. Locker will hold the package. So we have a current package, okay, and we have some relevant methods for the locker. Then we have a package class. For package, we have a size and using the same enums, we can rename it to size for more readability. Package type, it can be either a return package or a delivery package. The customer ID, customer who owns this package, and the locker ID where the package is kept. For customer delivery agent, we don't have any detailed information as such, only the contact info. It's really we have an admin. Other than that, we have implemented a strategy pattern for locker allocation strategy. So either we can go with random allocation or we can have size-based allocation. So both of these classes will implement the same allocate locker functionality. Okay. Then we have a locker service, which will, so here I'm showing the constructor because here we are doing dependency injection via the constructor for strategy pattern. Okay. Then we have an OTP service. Again, this is an interface. And we have in-memory OTP service implementation. So right now we are not storing OTP in some DB or something, just an in-memory service is there. Yeah. Then we have a notification service. Again, we can have email notification, we can have SMS notification, push notification. Right now, the only implementation we are adding, that is email notification. So we will either want to notify the customer or the delivery agent. Then we have the admin service. Admin, can take care of the stale lockers, and admins can, vacate a locker and stuff like that. So class locker controller is our main entry point of the system. Locker controller has a locker service, OTP service, the notification service, and it will perform the core functionalities, which is pickup package, return package, and the allocate locker for package. Okay. Other than that, we have identified the relationships, the class relationships. Okay, so you won't understand much from this. So let's go to the diagram. Okay, so this is the class diagram. I know it is not very, uh, not in a user friendly manner. I don't know why. Let me this out. Okay, so see, we have the locker controller. Locker controller is associated with locker service, OTP service, and notification service. We have all these services here. I'm sure it is not visible on the video. We don't have an option to slide as well. Here only we can see. Here we have the here we have the locker service. Locker service is locker services dependent on notification service, OTP service, and locker service. Sorry, locker controller is calling the locker service, OTP service, and notification service. Notification service, email notification is an implementation of the notification service. In-memory OTP service is an implementation of the OTP service. Okay. For locker, the locker is associated with a package. Package is dependent on these enum types, and locker is dependent on this enum type. Then we have delivery agent, customer, and whatever we have defined here in this UML, that is what is being drawn over here. Okay, so we have identified the class relationships and the attributes and the methods associated with each class. So it's time we can move on to our next step, which is API design. So for API design, I am keeping it short. Basically, these are the same things which we have implemented on our class diagram. Like for customer, we will have an API to reserve a locker for an order, right? Something like this, lockers reserve, because we are mainly operating on the lockers resource. Similarly, to pick up a package, they will visit a locker, at a special locker, they will pick up the package. Similarly, we will have some delivery agent APIs to deliver package into a locker and to release the locker in delivery phase. Both of these are working on the lockers source because we will mainly be changing or updating the lockers resource. Again, admin can have APIs for adding a new locker and updating a locker status. So we will just keep this short because it is not usually the main point of discussion, but still if it is touched upon, we can work on the APIs. Now let's move and let's try to code our solution. So I have created a project folder, and here I have created the sufficient folders like controller, enums, models, service, and strategy. So first, let's start with the very easy thing, which is implementing the enums. So I've implemented all the enums, locker status, pre-reserved, occupied, locker size, SML, and package type, delivery, and return. Now let's move on to the models. Okay. So we have implemented all the models. So for admin, we don't have much stuff. We have this. Let's also add the constructor for it. String name, this .id is ID generator. So this ID generator I've used in my previous video as well, so you can check it out there. So yeah. Other than that, I can have the data set of functions, data functions especially for both of these attributes. For customer, it's basically the same. We just have an email attribute. For delivery agent, it's entirely the same, nothing different. So we could have an abstract user, user class. And with that abstract user class, we can, derive or implement extend these classes. That is also another possible, improvement. Now we have this locker class. So for locker, we have the ID, status, size, and package as decided. So initially, when we are starting a locker or like basically instantiating a locker, we mark the status as free. We have implemented the is available method, which checks if the locker is available. Other than that, so only if it is free, it would be available. Okay. Other than that, assign package and release package. So when we assign package, we provide the package, and we also make the status as occupied. So when we release, we mark the status as free. When we reserve, we mark the status as reserved. Other than that, these are only the getter functions. Similarly, for a package, we have the ID, package size, type, customer ID, locker ID as decided. Similarly, when we instantiate a package, we are providing the ID, the package size, the type, and the customer ID. All this stuff here. Okay. So this is the current implementation for the models. Let's move on to the next. Let's move on to the strategies. Okay. So we have implemented the strategy classes. So this is the interface where we have locker allocation strategy, and we just have the function definition. Not that we don't have the implementation here because it is an interface. Okay. In random allocation strategy, what we are doing is we are iterating through the list of lockers. Okay. And we are filtering all the available lockers because even with random allocation, we can only allocate the lockers which are available, right? So we are filtering all the available lockers, and if it is empty, we are saying okay, no available locker found, and we are returning null. Otherwise, what we are saying is return available lockers dot get. And now here we are passing in a random index because it is random allocation. So to get the random index, we are using random rand.next int will give me a random integer within this range from 0 to this range. So here I have passed the size. We have also implemented the size based allocation strategy. So size based basically means that the size of the package should match the size of the locker. Okay. So here we have lockers. So again, I'm getting the package size from the input package, and I'm trying to find which locker can I assign. So I'm iterating through all the lockers. I'm filtering based on if the locker is available, because it obviously it has to be available. And then I'm figuring out what is the size of the available locker should be equal to the required size. Okay. And I'm running find first. Basically, it means from filter, whatever the list of, stream, whatever the stream it finds, just return me the first element from that. So if we don't have any element, then we will return null. Okay, so here also I can add a check if allocated locker is equal to null. I can add a print for our clarity that no lockers found using size based allocation strategy. Okay, here, and then we are returning the allocated locker. So let's move on and now implement the service classes. Now I've implemented all the service class. So for admin service, now what I've done is I've trimmed down few of the functions for the sake of simplicity. So here, rather than having multiple functions, I have made one function for marking a locker out of service, which the admin can handle. We have a notification service implement interface, which has the notify function, and email notification service is implementing that. And here we can have the business logic. We don't really need to implement the notify method. Then we have an OTP service. Again, it is an interface which will generate the OTP and validate the OTP. We can also have a function for invalidating an OTP. Invalidate OTP basically means just remove remove the OTP associated with that customer ID. So inside, if we go to the in-memory OTP service, so here we are maintaining a hash map for the OTP. Basically, like in Rapido, if you have seen, for one customer, we have the same OTP being used. So that is what we have implemented here. We have the same OTP. So here, basically, we have a mapping from customer ID to the OTP. Okay, so here we are generating the OTP, and this is validating the OTP. Let's also implement the invalidate OTP. So here what I can do is I will mark OTP store dot remove customer ID. So that way we will not have the entry anymore and the OTP will be invalidated. Okay. So this is done. Other than that, yeah, we have a locker service. So inside the locker service, we are maintaining a list of all the lockers, and we have a locker allocation strategy. So this is dependency injection where we are setting the allocation strategy via the constructor. Okay. And we have an add locker service which will add locker to the list of lockers, and allocate locker where we will call the allocation strategy allocate locker method. And once a locker is allocated, we will assign the package to it, and inside the package we will go and set the locker ID. Similarly, we have a release locker. So the function is almost similar. We are releasing the locker with the locker ID given. Other than that, we have a get available lockers or helper function. Okay. So yeah, Now let's move on to the main controller of the system. So I have implemented the locker controller. Okay, there are a few changes which I did when implementing the controller. So I have the OTP service, locker service, and notification service. Basically, locker controller is managing everything for us. So here we have a request locker function, which will get the customer and the package and assign a locker, allocate a locker to that package, generate a OTP, and will send the message to the customer that this is your OTP. Okay. And then we have a pickup package. So request locker is generating the OTP, right? Wait, I think I did a mistake here. I don't need the OTP here. I don't want the OTP. When the customer goes to pick up pick up the package, they have to provide the OTP. So customer needs the OTP, right? So what I can do is I can get the correct OTP here. String OTP can be. So now this OTP is being stored in OTP service. OTP service. Let's go to this OTP service. In here, what we can do is we can implement a public. This is a string, right? A string get OTP for this customer ID, and then we can return OTP store dot get customer ID. Okay, so we can add a check for if the customer ID doesn't exist. For now, let's continue. And in here, I can say OTP service dot uh, OTP service dot get OTP. Why don't I? Okay, I have to add this there. Get OTP for customer one dot get ID. So when we use the correct OTP, we should be able to pick up the package. With the incorrect OTP, we should not be able to pick up the package. Okay. So yeah, I was showing you the request locker. So here we are generating the OTP and the message that the locker is present in this. Okay, from the message I would have received the OTP. Anyways, and then the pickup package. So when basically the customer will go and pick up the message, the OTP will be validated. If the OTP is valid, we will release the locker. Okay. Otherwise, we would just prompt that it's an invalid OTP. Let me now run the code. Run. So the build is done, and now here if you see, let me rerun it once again. Basically there was an error due to which I added few login statements. So in the is available function, instead of using the locker status, I was using the size. That is why. Okay. So here what happens is when we allocate the locker, it sends this mail. Your package is in this locker and OTP. Okay. So the first time, if you see, I have simulated a incorrect OTP by manually providing a incorrect OTP. Okay. After some time, after a sleep of 4 seconds, I am providing the correct OTP as received as received by the customer on their message. So then they will be able to pick up the package. Okay. A few things which we can check is suppose I have small and medium. I can try saying I can go for, do we have a locker size? I don't have a locker size of this. So let's say if I have a big package, okay. Let me create another customer for this. Customer two, new customer, PB, birthday. Yeah. Okay. So now in here, I'll say customer two dot get ID. So now, controller will request locker for customer two and package two. Okay. Also, I can sleep. Let's just add certain delays so that we are able to understand what is happening. And let me rerun this. So now what happens is for this, we should be seeing an error message because we don't have a locker size of, size L. So we should be seeing an error message. Let's see what happens. Okay, so here you can see that it says no lockers found using size-based allocation strategy. And then this is also coming for the same user, for the same customer. And then we are getting invalid OTP. And then, after we provide the correct OTP, we are able to pick up the order. So this is it. I have not implemented the return flow because I'll just try to keep the system simple. Okay. So the coding, I think we're good with the coding part. So I can move on to the next step, which is, discussing the design patterns and principles we have used. Okay. So we have used certain design patterns and principles. So let's talk about the design. Let's talk about the design principles first. So we have used the SRP, single responsibility principle, because if you look at our code, locker controller is only doing one task. Locker controller is only allocating and releasing the lockers. So that is what the SRP states, that the services should have a single responsibility. OTP service is managing the OTPs. Notification service is managing the notifications. Okay, so we have implemented the SRP. We have also taken care of OCP, which is open closed principle, because if you see, we have two sizes. We have two allocation strategies: random allocation strategy and size based allocation strategy. So basically, strategy pattern goes hand in hand with OCP, because if I want to implement a new strategy for allocation, a new allocation strategy, I can simply extend my code. I don't have to modify the existing code. Correct. That is why we are using OCP, and we are also using LS interface segregation principle, because all our we have small focused interfaces. That's what ISP states, that we should not have bloated interfaces. Okay, and we are also implementing the dependency inversion principle. So if you look, so dependency inversion, we have implemented that locker service depends on locker allocation strategy, and not its concrete implementation, and not its concrete implementation. Okay. Other than that, we also have LSP, and we are taking care of LSP as well, because our strategies and services, they respect their interfaces. Okay. So they are kind of taking care of all the design principles. For interview perspective, we can mention a few of them. We don't have to necessarily mention all of the principles. Okay. Let's move on to the design patterns used. So first, which is very obvious, we have used the strategy pattern. Strategy pattern for locker allocation strategies. Okay. Again, for the notification service, we have the notify method. It's not a complete observer pattern, but somewhere we have touched upon the observer pattern. We can also implement the for observer, we have a subject. We have a subject and the observers. So here we have the subject notification service. We can implement the observers as well. So yeah, basically if we extend this, we can implement the observer pattern. Then we have taken care of dependency injection. Again, services and controllers take abstractions in constructors. Then we have the factory method. So basically, this can be a future improvement. Future improvement method. So we can use that to instantiate the database service or the application. So